All right. So what we want to notice is the slopes here. If I have a positive 1 slope or positive 1 in front of the absolute value, that means the slope of each line, one's a positive 1, one's going to be a negative 1. And then whatever point I have here, so in this case, this would be the point -3, 0. So that's this guy right here. You're going to have the same thing shown when we would have written this in point slope form. Okay? All right, no problem, Bishner. Thank you. So what we want to be able to do now, so let's go to some of these and see if we can kind of put these ideas together. Okay? So this says, below are the graphs and equations of more linear absolute value functions. Write the piecewise function for each. See if you can create a strategy for writing these equations. That's kind of what we were referring to above. Okay? So here's our absolute value function. So let's kind of write our piecewise function and see if we can recognize the pattern here. So if I ask you, we definitely need the slope of this line over here. So I'm again going down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So over here, my slope is a -1. Over here, I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. This slope is a +1. So if we were to write these, the first one would be a -1 for the slope. And then remember, point slope form is just this. That's where we're getting all of this from. The common point that we would use is right here. So we always want to use this common point. That is the point 1, -2. It's the vertex. Like we had a parabola, we called it a vertex. We'll also refer to the shared point as a vertex. Okay. So if I now go to the x coordinate is a 1, so I'm going to plug in a 1 right here. So let's get rid of that and plug in a 1. So we always have this minus, and this is a 1. The y coordinate is a 2, so I'm going to come over here to this y coordinate. I'm going to replace that with a 2. And then that's the equation for the first line. The second line has a slope of a +1, so we're going to put that in front. And then the same exact thing would have to play out here, right? Like the same x coordinate I would use, so I'm going to put a 1. Oops. So let's put our 1 there. It has the same y coordinate of 2, so we're going to put our 2 right here. Yeah, Cam?
I'm kind of confused for your point. Why do you have a 1 negative?
That's a good question. Yeah. Because I was too excited. Definitely a +2. And then I have the +2 here. I don't know why I put the negative in that one. Yeah. Okay, thank you for catching that so we don't confuse everybody. Let's do our quick domain here. So this line starts at 1, and we're anywhere to the left of 1. So as long as we are left of 1, so less than or equal to 1. And then the right-hand line starts at 1, and we go right forever. So anywhere greater than 1. All right, so now let's compare these two things. Notice how instead of using, so if I just look at the stuff I shade here, aren't these 3 things that I'm shading right now pretty much the exact same thing, except when we did the absolute value, we used the bars versus parentheses. All right, so these, what I have in blue, are identical, except parentheses versus the absolute value bar. Notice what our slope was in this case. Our slopes were a -1 and a +1. So what that means is the coefficient of this should be a 1. And then what we would need to know is whatever this slope is, that's the positive and the negative slope of each of those lines. So if I have a 1 right here, I know that one slope's a -1, the other slope's going to be a +1. All right? So let's do this real quick. If I ask you, if I were to cover this up, so pretend this isn't there right now. All right, so there we go, it's gone. You cannot look at that if you don't have it. If I now ask you to write this as a piecewise function, what we would have is, if there is a 1 in front of this, that means the slope of the first one's a positive or a -1, the second one is a +1. Those have to be the slopes of those 2 lines. If we then went ahead and did our point slope form, notice how we're adding a 2 on the back end of the absolute value function. So that means each line would have a +2 on the back end. And then a little sneaky here, since we're not subtracting anything inside of this, what we basically would have is zeros right here. You don't necessarily need to show the zeros, but what this would mean is one line has a slope of a -1, and we'll verify this in a second. The other line has a slope of a +1, and then the vertex point, the shared point, should be 0, 2. And that's without looking at that graph. So if I now erase all the scratching out over here, if we now look at this, down one, right one, down one, right one, down one, right one, we can see this does have a slope of a -1 like we're supposed to. This is up one, right one, up one, right one. This has a slope of a +1 like we're supposed to. And then if we look at our vertex point, 0, 2, we got that by just looking at this, 0, 2. And then again, 0, 2 in our line. Okay? All right, so now the test. It says graph the following linear absolute value functions and then write the function as a piecewise function. All right, how many do I have of these? I want to make sure I don't do too many of them without you trying. 3. Okay, perfect. So let's do this one together, and then we'll see if we can do 13 and 14 on your own. So I look at number 2. First thing we want to know is what point am I going to plot over here? I need to put the vertex point. So the first thing you want to identify is what's our vertex slash what's the shared point, and we should be able to identify that by just looking at this equation. What I am going to ask you to do is put a little +0 on the back end of this, just so we can kind of see all of it. Plot right now, see if you have any clue what I'm talking about right now, or if it's like the peanuts and you just hear the wonk, wonk, wonk. See if you have any idea what point to plot right now. That would be our vertex point, the shared point, and we should know that by just looking at this equation right here. All right, Cam, you got your hand up. What point do you think is our vertex shared point?
4, 0.
Good. That's our shared point. So since this is x minus a 4, that means 4 is the x coordinate, 0 is your y coordinate. So we're going to plot that point. So go to 1, 2, 3, 4 on the x-axis. You're going to plot that point. The other thing we should now be able to identify are the 2 different slopes that we're going to count off from this point, because we better get a V out of this, right? Absolute values are always going to be a V shape. So if I now ask you what are the slopes of those, write down what you think these 2 slopes would have to be based upon, again, nothing more than looking at this equation right here. All right, go ahead, Kim. You got your hand up. What do you think?
-1 and +1.
Okay, and how did you know that?
When you look at the absolute value function, you can see that there's nothing under the 2 dashes, and we usually don't have to put anything to 1.
Good. So he's saying he looked at this absolute value equation. In front of the absolute value bars here, there's nothing written, so that's implied there's simply a 1 right there. So because it's a 1, that means one has a slope of -1, one has a slope of a +1. So go to this point now. Let's actually graph this one first, the slope of a +1, because I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. So this is 1/2 of our V-shaped curve that we always get with an absolute value equation. Just be a little more careful with this one. And the only reason I say that is if I now ask, I'll do it in red. If I ask you to count -1/1, for most people, your first thought is to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. But for right now, all of our V's should be opening up or down. We will eventually get to V's that open to the side. So instead of counting this as down 1, right 1, down 1, right 1, down 1, right 1, we would want to go up 1, left 1, up 1, left 1. Notice they all fall in line together, regardless of the direction, but this is the half that we want. Okay? And then that's our graph. That should also now allow us to write this piecewise function pretty quickly. Because if I want the, actually let me do this in red. If I want the red line, don't we know the red line has a slope of a -1? And then notice this was x minus 4 and a 0. So that's the same exact thing we do with our piecewise function. The 0.4 comma 0 is the point that we would use. The black line has the slope of a positive 1, but we're still using that exact same point, x minus 4 plus a 0. That's the equation of the second line. Okay, now we would want to put our domain here. So the red line is only good if we're to the left of 4. And then the black line is good for all x values to the right of 4. All right. So now 13, without any of me writing anything down, I'll give you 2 minutes. Finish 13, see what you think here. See if you can first graph that, and then see if you can write this equation. No, just, oh, these two? Yeah.
Oh, I have that. Needs to be working.
Yeah. These two I knew would be good. They're much more reliable than our technology in this room. Yeah, right. All right. Jenna, what do you think for our vertex points? Good. So that should be our vertex. If you notice in here, they don't put the 0, but it's really just an x minus a 0 plus a 1. So that's our vertex point. So that's the point that you should be plotting. And then Ahmed, what is the first slope? Good. And the second one? Good. And we can get that because in front of the absolute value, there isn't anything there. And the reason there isn't anything there is we don't have to write anything if the value is a 1. So we know we're going to get the positive and the negative slope of that. So same thing we would have just done. Let's count the positive one first. We're going to go up 1, right 1, up 1, right 1. And we get that line. If we count off the second one, again, don't go down 1, right 1, because it's going to take us and make us open right. We want to open upwards, go up 1, left 1, up 1, left 1. And then this should be our graph. Okay? Good. When I now go to write that equation, we're just going to use these two things. Oh boy, that was my fault. Not my computer's fault that time. I'm not going to blame it. I'm going to use these two pieces of information to write my equations now. So I'm going to take the slope of a negative 1. Now I use parentheses 0 minus a 1. And notice it's really just the same exact thing up here, except we're using parentheses instead of these. And then positive 1. And then same thing, x minus 0 plus a 1. All right, hopefully we're understanding this. All right, last one of the day, really, I think, if I remember correctly. Yeah. So do that guy. Little different. Yeah. See what we get. Find the point that they're sharing. Identify what our slopes are. Graph it. Write your two equations. Let's see. All right, so if I ask you for your shared point, Cam, what is it?
2, -2, 1.
Good. So just be careful of this now. Make sure we have negatives. My guess, if we all 25 were here, as we walk around, I would see some positive 2's right there. Since this is now an x plus a 2, that means that r2 had to have been originally a negative value. All right, so just be careful of that one. And then definitely the positive 1. So that's the point we're going to plot. So -2, +1. And then what are our two slopes, Cam?
Our two slopes are -3 and +3.
Good. Since we now have a 3 in front of this, that means from this point, I'm going to go up 3, 1, 2, 3, right 1, 1, 2, 3, right 1. That's the positive slope. And then the -3, again, we're not going down 3, right 1. We're going to go up 3, left 1, up 3, left 1. And then that should be our equation. Keep in mind, this is very, very, very similar to parabolas, correct? I know we haven't done that in many months, but remember how if I put a bigger number in front of it, our parabola got narrow? It's the same exact thing with these. If it's bigger than 1, we get more narrow. Didn't we really shift this left 2? Like, right? Aren't we over here 2? And then it got bumped up 1 because of that +1. Really similar ideas to what we were dealing when we were dealing with all those parabolas, the stretching, the shifting, all that good stuff. All right. Then we can now write our equations. The first one has a slope of a -3. And then we basically just recopy these, right? Except we use parentheses, x plus 2 and then +1. And then the second slope has a slope of a +3, x plus 2 plus a 1. That's the equation of those two lines. The first one, we are starting here at a -2, so we're good for that first equation if we're less than or equal to a -2, and then anything to the right of that one would be the next line, so we would say x is greater than a +2. All right? Okay, good. So we do have, keep in mind, we have homework due tonight. That was those 3 questions. All right, we just did one of them, so hopefully we have that. You don't have too much, but you're also going to get homework tonight. I want you to do because I'm looking at the packet right now. Your packet's messed up. If you look at the page of 23, on the bottom of 23, there's just a random table there. So if you flip that and you go to page 24, that's where I'm going to have you start off. Okay, so I'm going to have you do page 24, and then I'm going to have you start at number 8. Whoa. Page 24, number 8. These ink to shape I still have clicked. That's the problem. I was playing around with my new toy earlier, Ahmed. Yeah, now I got an arrow. Oh well. So page 24, number 8 through, I think it was 19. All right, so yeah, 20 through 20. Okay, but similar stuff we were just doing. Look at this equation here and using the given information to write the indicated form of the equation. So if I give you this, what this is asking you, write the let's do this one real quick, just so we know. When you come down here, I want you to label your vertex. You're going to graph this, just kind of put all this stuff together. So actually, let's kind of do this one. I haven't had you actually do this from a graph. Write the equation of that graph. It's an absolute value equation. Can we put that together and now go the opposite of what I've had you been doing? Okay, so I'm going to do something here to make it kind of recall when we did parabolas. Remember how we would put the A, the H, and the K, all that good stuff? It's the exact same thing as a parabola, except we're using those bars. So the first thing, if I ask you what number needs to go in front, like what's our A? That should be what? Yeah, Cam, 1. Because we're going to go, if we look, my slope over here is a positive 1. My slope over here is a negative 1. So what that then means is the coefficient of this had to have been a 1. So whether you write that or not is optional. We don't have to put the 1 in. If we then talk about what's the x coordinate, you're going to look at this point here, our vertex point. We can now just look at it. That's a -6, -4. That's this point. I'm sorry, -5, -4. Let me rewrite this. So we would now do x minus a -5. And this is a nice way to kind of understand if we ever, like we did in that previous question, notice how we have a double negative here. So if we ever end up with this as a plus, that actually tells us that our x was a negative value. So that should become x plus a 5. And then on the back end, we should have a minus a 4. So I get rid of the plus, and we should have a -4. This is the equation of that graph. All right. If you can walk out of here understanding those couple little things, then you're on track. All right. Okay. That's all I got. Have a good weekend. We will see you guys all on Monday. All right. Take care.